In the last class, we have seen how the structures are defined so that the structures can have arrays as the members. Okay, now let me explain this concept once again. Briefly, I'll explain. So, name is an array of 10 characters. Then we have marks 1, marks 2, marks 3. I want to store marks of 3 subjects, and then I want to store average marks also. So, name is an array of characters. So, I use the keyword char. Marks 1, marks 2, marks 3 should be of type integer. So, I write int. Average is of type float. All these variables must be enclosed within braces, and here I use the keyword struct, and here I write type def. The moment I write type def, it becomes a type defined structure. If it is a type defined structure, definitely you should have one identifier, and that identifier we call it as user defined data type. So, here I write student as a user defined data type. Okay, now the moment I define a structure something like this, remember memory will not be allocated. So, if I want to allocate the memory, I have to associate this structure with one variable. So, I declare a variable s which is of type student. Now, what will happen? Memory will be allocated for this field name, and next marks 1, marks 2, marks 3, 2 bytes for marks 1, another 2 bytes for marks 2, another 2 bytes for marks 3, and for average we have 4 bytes. So, all these things can be accessed using the common name s, because I am using the variable s. Now, what is the total size? 10 here. 10 plus 6, how much? 16. 16 plus 4, 20 bytes. So, totally the size of this structure is 20 bytes. Now, I slightly change this. Now, here what I do, instead of here we have marks 1, marks 2, marks 3, all are of type what? Integer. So, what I do, instead of using 3 variables here, I want to use only one variable. So, here I change this and I write marks of 3. Remember, marks is an array of how many integers? 3 integers. So, here we have 3 integers. So, instead of writing 3 integers like this, I can say marks of 3, which is of type what? Integer. Now, if I say a is a variable of type student, now tell me what will happen? Memory will be allocated for name having how many bytes? 10 bytes. Then we have marks 1, marks 2, marks 3. Totally we have marks is an array. When I say array of how many integers? 3 integers. So, 2 bytes for first integer, another 2 bytes for second integer, another 2 bytes for third integer. So, totally we have 3 integers, each of which takes how many bytes? 2 bytes. So, here what is the common name given for this? Marks. So, this field is identified by marks of 0, and this field is identified by marks of 1, this field is identified by marks of 2, and so on. So, here you have marks 1, marks 2, marks 3, marks 4, and so on up to marks 10. Here what you have to write? Marks of 10. In that case, we have marks of 0, marks of 1, marks of 2, and so on up to marks of 9. And finally, what we have here? Average field, which is of type of float. So, 4 bytes will be allocated for the field average. All these things can be accessed using the common name a. So, here this also occupies how many bytes? 20 bytes. So, here we have separately declared marks 1, marks 2, and marks 3 as integers, but here we say marks is an array of 3 integers. So, the number of bytes occupied by both the structures remains the same. Okay, now here 3 fields are there. All those 3 fields takes how many bytes? 6 bytes. Each field takes how many bytes? 2 bytes. So, instead of writing 3 integers, here we can say marks of 3, and it also occupies how many bytes? 6 bytes, where each integer takes 2 bytes. Okay, now let us see how to start writing the program. See here an array such as marks of 3. Here this is marks of 3. Thus, can be a single member representing a group of marks of 3 subjects. If I want marks of 10 subjects, what should be the change here? I just change this to marks of 10. Here, whereas I should write marks 1, marks 2, marks 3, marks 4, and so on up to marks 10. Okay. Now, we know when we have to use arrays inside a structure. So inside a structure, if we have a group of variables having the same data type containing similar information, then it is better to use arrays. So what is the advantage of using arrays inside a structure? It is easy for the programmer to manipulate a group rather than manipulating individual members of a structure. Okay, now let us see how to start writing the program. Now let me write one function to read the marks of the students, and another function to display the marks of n students, and another to sort the student record based on the names. So I write A is of type student. So the moment I say A is of type student, what will happen? Memory will be allocated for name, 3 bytes for integers, and those 3 locations are identified by marks. So how to access this field? I can say marks of 0, marks of 1, marks of 2, and for average, how many bytes? 4 bytes for average. So this how memory is allocated if you have a variable A which is of type student. Now if I want to have an array of structures, so here I have to follow the variable A with square brackets. Now what will happen? N is of type say integer. So A is an array of student records. N is of type integer. This n indicates how many student records are possible. So here I write 1 record, 2nd record, 3rd record, and so on. You can keep writing. Here I will assume n is equal to 3. So I have 3 student records. Now I have to read. So to read, we write one function by name read student details, and here I write void. Remember, this is a function declaration. It is also called a function prototype. It ends with what? Semicolon. Next, we can write another function which is used to display the student details. So I can write student details. A is of type student, but remember A is an array and n represent what? Number of students. So here I say A is an array of student, n is of type integer, and these 2 parameters must be enclosed within parentheses and should end with a semicolon. Next, we write another function which is used to sort the student details. For that also we require A as an array and n is of type what? Integer. So what is A? A is an array of student records, n is of type integer, and enclose these 2 parameters within parentheses and end with a semicolon. Okay, now let us see how to write the function. Let me call the function read student details. Assume for the time being that all these 3 functions are built-in function, but really they are not. Assume for the time being. And if you assume 3 functions are there, now let us see how to write the main program or the main function which uses these 3 functions to read the student details, to write the student details, and to sort the student details. So here I call the function read student details. Tell me how many parameters are there? 2 parameters are there, A and N. So here also we write A comma N. Here A and N are called what? Arguments. Arguments must be enclosed within parentheses and end with a semicolon. Next, after reading the student details, what we have to do? We have to sort the student details. So call this function sort student details. For that, we require the student information which is stored in the variable A, and we require another n. What this n represent? Number of students. And enclose these 2 arguments within parentheses and end with the semicolon. Now here we read the student details, and the details are available in the structure variable A, and here we sort the student details, and the sorted student details are available in the variable A. And finally what we do? We display the student details which is available in the variable A. All n students information will be available in the variable A. And what this n represent? Number of students. So enclose these two are called what? Arguments, and enclose them within parentheses and end with semicolon. Now if I want to read student details, first of all I require the variable n. So here how to read the value for n? N is an integer, so we write ampersand n. Because it is an integer, we have to use the format specifier %d. and using which function I can read the value into n, using scanf function. So I write scanf. Normally before scanf we write printf. So here I write printf, enter the number of students. Now all these statements should be repeatedly executed. If I want to read the student details, call this function. Sort student details, call this function. Write student details, call this function. Now think of what are all the variables we have here, n and a. N is one variable, a is one variable. So here I write n and another a. But remember, a is an array. So I write a of 10. Here how many student records are there? 3 student records are there. Here I wrote a of 10. It indicates maximum of 10 student records you can have. Now tell me, n is of type what? Integer. So I use a keyword int. What is a? A is an array of a student record. So I write capital letter student. So student is already defined here. Now all these statements I enclose within braces like this, and here we write void main. The declaration of printf and scanf is available in stdio.h. So you can include stdio.h in the beginning of the program. So I hope you understood how to write the function main. Now the problem is, we assume that these 3 functions are available. Now let us try to define these 3 functions one by one. First, let me concentrate on how to read the student details using this particular function. Okay, now here 3 student information is available. Let me add one more. I can write a of 3. To get one more student information, I can say a of 4. Now here tell me how you access this field name. You can say a0.name. How you can access this field? a1.name. What about this? a2.name. This is a3.name. This is a4.name. So instead of writing a0.name, a1.name, a2.name, a3.name, a4.name, in general let me use a of I.name. And name is a string. Because it is a string, if I want to read a string, what is the format specifier I should use? Percentages. So here I write percentages. So to read a string into this, which function I have to invoke? Scanf function I have to invoke. So I write scanf percentages a of I dot name. Normally before scanf, what I write? Printf. Printf what? Name equal to. So here I write printf name equal to. Next, now here suppose I enter RAM from the keyboard. What will happen? RAM will be copied into this memory location. Now I want to enter something into average. So I write ampersand a of I dot average. What is it? It is of type float. So what is the format specifier? Percentage f. And here I use a scanf function. So before that what we write? Printf average equal to. Suppose average marks is 24.5. So if I enter 24.5 and then press enter, what will happen? This 24.5 will be copied into this particular field. Now we can enter 3 marks. So how we can read marks here? So this will be, if you observe, what is this field called? Marks. Using a, how you access this field? A of I dot marks. So here I write ampersand a of I dot marks. If I say a of I dot marks, what I will get here? Marks of 0, marks of 1 and marks of 2. So how many integer values I have to enter from the keyboard? 3 values. One is 25, 24 and 23. I want this 25 to be copied into this location. And this 24 I want to copy into this location. And finally I want to copy this 23 into this memory location. Now, how is it possible using marks? So how you can access this field and this field? Using the subscript 0, 1 and 2. So instead of using 0, 1 and 2, in general I write j here. So what is the subscript value? Subscript value can be 0, 1 and 2. So instead of using 0, 1 and 2, in general I can write what? J. So what can be the initial value of j? 0. Next j can be 1, j can be 2. I have to read integer into these 3 locations. So what is the format specifier? I should use a percentage d. So if I want to enter the data from the keyboard and copy into this memory location, I should use which function? Scanf function. So here I write a scanf. And before this, let me display the message. what should be the initial value of j here? 0. If j equal to 0, what is the output we get? Marks of 0 equal to. Marks of 0 equal to, and here we enter. So this has to be displayed onto the screen. So for that I use a printf statement. Remember, execution of these two statements should be done repeatedly. So enclose within braces like this. Why we have to repeat the execution of this? Because we have to read how many marks? 3 marks. So what should be the initial value of j? Initial value of j will be 0, next j will be 1, j will be 2, and so on. So because we have initial value and final value, each time the value of j is incremented by 1, I am forced to go for which loop? For loop. So I write for what? J is equal to 0, j should be less than or equal to what? 2. Instead of writing less than or equal to 2, I can write j less than 3. And each time the value of j should be incremented by 1. See, initially j is 0, j becomes 1, j becomes 2. So the value of j should be incremented by 1. So here what I write? J plus plus. So this is expression 1, semicolon expression 2, semicolon expression 3. All these three expressions must be enclosed within parentheses like this. Okay. Now, if you observe how many parameters are passing for the function read student details, 2 parameters are passing. One is a and another n. A here corresponds to a here, n here corresponds to n here. So apart from a and n, think of what are the other variables you are using here. Apart from a and n, we use which variable? I here. Now one more thing is, now here can you tell me what is the initial value of I? Initial value of I will be 0. Next I becomes how much? 1. Next I becomes 2, I becomes 3, I becomes 4. So if I execute these statements repeatedly, how many times? 5 times. I can enter 5 student details like this. So to enter this information, what should be the initial value of I? 0. So here, now see what happened here. If I execute this loop, how many times this loop is executed? 3 times the loop is executed. So first value entered will be copied into this field, then 24 will be copied into this particular field, and 23 will be copied into this field. And we have entered only information of one student. So if I execute this, all these statements will be used to enter the student details of first student, because initial value of I is what? 0. So to enter student details into this location, the value of I should be 1. So initial value of I is 0, next I becomes 1, I becomes 2, I becomes 3, and I becomes 4. So all these statements should be repeatedly executed. So I enclose them within braces like this. So here I open the brace and here I close the brace. Now here I use a keyword for what should be the initial value of I. Here observe this, what is the initial value of I? 0. So I write I equal to 0. Next, what can be the final value of I? 4. That means I should be less than or equal to 4. Here you have to write I less than or equal to 4 or I less than 5. They are one and the same. So instead of writing 5 here, I write n in general. And each time if you observe, the value of I is incrementing by 1. So how to increment the value of I by 1? I plus plus. So this is your function, and we know a and n are the parameters. Apart from a and n, tell me what are the other variables you are using here? I and j. So you can write int I comma j. And all these statements must be enclosed within parentheses, and this has to be moved here. So we can write void read student details and so on. So this is how we can enter n student information. Next, after reading n students information, let us try to arrange the numbers in ascending order. Arrange the student records in ascending order. Now tell me, what is this logic? This logic is used to arrange numbers in ascending order. But my intention is not to arrange numbers in ascending order. I have to arrange student records in ascending order, in alphabetical order. So here let me write, what is the keyword we have here? For. I write for. Then j is equal to 1. I write j is equal to 1. J should be less than or equal to n minus 1. Instead of writing j less than or equal to n minus 1, here we can write j less than n. each time the value of j should be incremented by 1. So expression 1, expression 2 and expression 3 must be enclosed within parenthesis. And the entire for loop, let me enclose within this for loop. So open the brace and immediately close it. So inside this for loop I have to write this one. Now what is the keyword we have? So I write for. Next what we have? I is equal to 0. Next what is the final value of I? N minus j minus 1. So here what should I write? I less than or equal to n minus j minus 1 or I less than n minus j. Each time the value of I should be incremented by 1. So I write I plus plus and enclose these three expressions within parentheses. Again open the brace and immediately close it. So within this for loop what we have to write? If statement here. Now if, so here also I write if only. Now we have to, here we are comparing two numbers a of I and a of I plus 1, but in our example we are supposed to compare a of I dot name with a of I plus 1 dot name because we are arranging the student records in increasing order of the alphabets. So in increasing order. So here I say a of I dot name. What is the next one we have? A of I plus 1. So here what to write? A of I plus 1 dot name. For comparing we can use which operator? Greater than or less than. Here what is the operator used? Greater than. But remember this greater sign we can use only for integers, floating point numbers, characters and double values, not for string comparison. For string comparing we use one function by name strcmp. If a of I dot name, if it is greater than a of I plus 1 dot name, the function strcmp returns a value which is greater than 0. So here I write greater than 0 and the entire expression must be enclosed within a parenthesis like this. Okay, next. So if this particular condition is true, how many statements have we have to execute? 3 statements we have to execute. So all those 3 statements are enclosed within the braces. So I write these statements as it is. Next, apart from a and n, here we are using a and here we are using n. Apart from a and n, tell me what are the other variables you are using? I, j and temp. So here we write I, j and temp. I and j are of type what? Integer. Temp is of type student. Now all these statements I enclose within the braces like this. And here what we write? Void. What we are doing? We are comparing. We are arranging the student records in increasing order of the names. So here I write sort the student details. And what we require? A which is an array and n which represent number of elements. So a is an array of what? Student and n is of type what? Integer. So these two parameters must be enclosed within a parenthesis. So I hope you understood how to convert a general algorithm into a specific function like this, which is used to sort the student details based on what? The name. So alphabetically we arrange the names and corresponding marks we should display. And let us see how to display using the next function. Suppose I want to arrange student details only. I have to sort the student details not based on name. I want based on the average marks. In that case, don't use strcmp. Here what we have? A of I greater than a of I plus 1. On similar lines I can write a of I dot average greater than a of I plus 1 dot average. So change this to a of I plus 1 a of I dot average greater than a of I plus 1 dot average. And if I want to arrange the student records based on only marks 1, so what you can write? If a of I dot marks 1 greater than a of I plus 1 dot marks 1. So if I want to arrange student records based on marks 3 only, then here you write if a of I dot marks 3 greater than a of I plus 1 dot marks 3. Rest of the logic remains the same. I hope you understood how to sort the student details based on the name, marks or the average marks code. Okay, now we see the last function which is used to display. What I have to display? Name I have to display and I want to display average also. So let me write a of I dot name, a of I dot average. So one is name and another is what? A floating point number. So what is the format specifier I should use here? Percentage S and percentage F. So I write percentage S and percentage F. So if I want to display this information, I have to go for which function? Printf function. So I write printf. Next, so here what we did, we have displayed the name as well as average marks. Now let us try to display marks. So here what we have? A of I dot marks of j, and I want to print marks. How many marks I have to print? 3 marks I have to print. So here j can be 0, j can be 1, j can be 2. So in general, let me write here, I write percentage d, display one integer value. For displaying one integer value, what is the format, what is the function I should use? Printf function I should use. Now to display marks of 0, j should be 0, then j can be 1, then j can be 2. So this printf should be repeatedly executed for the value of j ranging from where? 0, j less than 3 and j plus plus. So here we are printing name and average, and using this for loop we are printing marks of how many subjects? 3 subjects where j ranging from 0 to 2. Now all these statements should be repeatedly executed for all the values of I. So I enclose these 2 statements within the braces. So here I write for, can you tell me what is the initial value of I? 0. I write for I is equal to 0. I less than n, and finally we write I plus plus. So enclose expression 1, expression 2 and expression 3 within the parentheses. Normally before printing we display the message. So here the sorted student records are. I write, and to display this message on the screen, what is the function I should use here? Printf. So that's all, our job is over. Now tell me what are all the variables I am using here? I am using, j I am using. So we write I is of type what? Integer, and here j also I should write. Int I comma j you should write. And what is the return type? Void. Name of the function, write student details. A is an array and n. A is an array of what? Student records. N is of type integer, and these 2 parameters must be enclosed within parentheses. These 2 parameters must be enclosed within parentheses. So I hope you understood how to write the function, write student details also. So what is the mistake here? I have not declared the variable j. Here you should write int I comma j. That's all, our job is over. Now let us write the complete program for this. So this is the type define, and here we have how many functions? 3 functions. One function to read the student details. For that we require a, which is an array of student, and n is of type what? Integer. Enclose them within parentheses. Similarly, void write student details. A is an array and n, A is an array of student, n is of type what? Integer. And let me write the final function, void sort student details, and here again we say A is an array of students and n is of type integer. Now let us call the function, let us write the function main. I write student details. So parameters are a and n. So here arguments must be a and n only. Next, let us call sort student details. So here I write sort student details, same number of arguments, and here we write a comma n. And finally, after sorting, where is the result? Result is in the variable a. So let us try to display the sorted student details. Let us try to print the student details. So what is the statement I should write here? Write student details. So here I write student details. Arguments are a and n. Normally, before reading the student details and copy that into a, for that what is required? N is required. So here I write ampersand n. So scanf percentage d ampersand n. Remember, normally before scanf what to write? Printf. I write printf, enter the number of students. Now tell me what are all the variables we have? N and a. N and a is an array, n is of type integer, a is an array of students. All these statements must be enclosed within braces like this, and here we write void main. The declaration of printf and scanf is available in stdio.h, and so go here and write hash include stdio.h. Can you tell me why we use string.h? The reason is, if you observe this sort student details, there we have used one function strcmp. strcmp stands for string comparison. So whenever string functions are used, their declaration is available in string.h. So include string.h in the beginning. I hope you understood how to write a structure containing arrays and how to manipulate, how to read, how to display, and so on. Now the next topic is, let us see how to pass the structures or its member to the function. The various ways to pass the structure or its members to the functions are, first one is passing members of a structure. Maybe in the arrays chapter you have seen the different ways of passing parameters are, one is passed by value and another is passed by reference. So here passing members of a structure, it can be done either using pass by value or pass by address. Remember, three different ways of passing parameters are there. One is pass by value, pass by address, and pass by reference. Pass by reference is not there in C language, only pass by value and pass by address is there. Pass by reference is there only in C language, it is not there in C++. It is there in pass by reference is there only in C++, it is not there in C language. Now passing the members of a structure, it can be done either using pass by value or pass by address. Next, passing the structures. This also can be done either using pass by value or here we separately specify passing the address of a structure. So here when we say passing the structure, it means it is passed by value. Here we are passing it by address. Now let us see what do you mean by passing structures, how to pass structure members to various functions. Let me explain with a simple program. Suppose we have a fraction, 3 divided by 8 is a fraction. It consists of numerator and it consists of denominator. Numerator is integer, denominator is also integer. So here I write numerator n, it is of type integer, denominator d is of type what? Integer. And I want a fraction. I want fraction as a single entity. So what I do, I enclose these two declarations and here I write type def struct. And I want to treat this as a fraction. So using this when we say type defined structure, we have to associate this structure with an identifier, and that identifier call it as what? A fraction. Fraction now is a new derived data type which is derived from already existing data types such as what? Integer. So to define a fraction, fractions cannot be manipulated in C language just like that, like a normal using normal operators and so on. We have to have a structure because fraction part can be manipulated using structures like this, otherwise it is very difficult. Suppose this is the first fraction, I have to multiply that with the second fraction and the result is 3 into 4 how much? 12, and 8 into 7 is how much? 56. So here we are multiplying two fractions and the result 12 divided by 56 is available. Now let us see how to accept these two fractions and display this particular result onto the screen. Suppose I have a variable a, b and c. Why I need 3 variables? Because we have 3 fractions. I will call this as a, I will call this as b, and I will call this as fraction c. So a, b, c are of type what? Fraction. The moment I write, if I say fraction a, b, c, it is an instruction given to the compiler. By looking at this, what the compiler will do? It will allocate the memory for a. A is of type what? Fraction. It means it has one numerator and it has one denominator. So here I write numerator and denominator. Both can be accessed using the common name a. So a is a fraction. consisting of numerator and denominator. That is the meaning of this. A is a fraction which has a numerator and which has a denominator. Similarly, there is another variable b. So, a separate memory for numerator and denominator is available, and those two memory locations are identified by the name b. And we have to store the result in C. So, C is also a structure. So, C is also a fraction consisting of numerator and denominator. So, for C, numerator 2 bytes, denominator 2 bytes, all these two fields n and d can be accessed using the common name C. So, this is how the memory is allocated for the variables A, B and C. Okay, now, this 3 divided by 8 I want to copy here, because this is the first number, first fraction. That first fraction A I want to copy here. This 3 should be copied into which field? N field. So, how we access this field? A dot n. So, here I write ampersand A dot n, and here what this, how to access this? Ampersand A dot d. So, here I have to enter one integer. This is another integer. So, I require how many fields? 2 fields, and both are of type what? Integer. So, here 3 divided by 8, this is 3, then I have to write one slash, and here I have to write what? 8. So, if I want to read 3 and 8, 3 can be copied into A dot n, 8 can be copied into A dot d. So, to read 3/8 from the keyboard, what is the statement I should use here? Scanf. Now, normally before this we display a message, say fraction x divided by y. Now, look here, what is the message I get? Fraction 1 x slash y. Here, because of this slash, you have to type 3/8 from the keyboard. If you type 3/8 from the keyboard, 3 will be copied into A dot n and 8 will be copied into A dot d. So, like this, a first fraction can be read into the variable A. Now, what about 4 divided by 7? This is second fraction. How to access this? Using the variable b dot n and b dot d. So, b dot n, b dot d, because you are reading from the keyboard, we use the ampersand, and both are what? Integers. So, if you observe, both are integers. So, what should I write here? Percentage d, percentage d. Again we use which function? Scanf. So, if I enter 4 divided, normally before scanf, before the scanf, what we write? Printf. So, I write printf, enter the fraction 2. Now, if I execute these two statements, if I enter 4 divided by 7, can you tell me what will happen? That 4 divided by 7 will be copied into b dot n and b dot d. Now, we have read one complex number, we have read another complex number. Now, let me see how to write a function or how to write a program to multiply the fraction a, b and store the result in C. Before that, so here I have to multiply a and b. So, what is the operator to be used here? Star, and the result must be copied into variable C. So, here I write equal to. Now, let me write one function which is used to multiply two numbers. So, x and y. Let us multiply x and y. Let us return the result. So, how to return the result to the main program? We can write return here. There is only one statement I enclose within the braces. Now, tell me, what is the return type here? Integer. I told that we are multiplying two integers. So, this is int has to be followed by what? Name of the function. What is the name of the function? Multiply. For multiplying, what you require? Two operands. One is x and another y is required. So, I write x and y. X is of type integer. Y is also of type integer. Remember, immediately after multiply, whatever parameters are there, all those parameters must be enclosed within parentheses. So, this is your function to multiply two integers. Remember, we are not multiplying two fractions, we are multiplying only two integers. If x is 2, y is 3, what we do? 2 into 3. What is 2 into 3? 6. We say return 6. That 6 goes to the main program here. Now, let us here we have fraction 1, here we have fraction 2. Fraction 1 is available in which variable? A. Fraction 2 is available in which variable? B. So, let me access the numerator and the denominator. So, in the numerator we have 3 and 4. 3 into 4, how much? 12. So here we have 3, here we have 4, 3 into 4. First of all, we have to access 3. So how to access 3? A dot n. And then we have to access this 4. How you access B? How you access this 4 using the variable B? We write B dot n. Now here, what is A dot n means 3. What is B dot n means 4. 3 into 4. How much? 12. So 12 should be the result. So given this integer 3 and this is 4, we have to multiply. Where is the multiply function? Here. So let us call this multiply function. So here I write multiply. Now what will happen? What is A dot n? 3. What is B dot n? It is 4. So this is 3 and this is 4. That 3 is copied here, 4 is copied here. So x is 3, y is 4. X into 3, 3 into 4, how much? 12. When you say return 12, that 12 comes back here and the entire function is replaced with what now? 12, and that 12 I copy into which variable? C dot n. So that is the reason 3 into 4, how much we get? 12. So 12 should be written only in which field? Numerator field. Now on similar lines, you should be in a position to tell how you get the result for the denominator. Again, say A dot denominator. What is A dot denominator? 8. What is B dot denominator? 7. So here I write B dot D. We have to multiply 8 and 7. So what is the function used? Multiply. What will happen? This 8 and 7 will be copied here. So 8 and 7. 8 is copied into 8. 7 is copied. 8 is copied into X and 7 is copied into where now? Y. 7 into 8, how much? 56. So 7 into 8 is 56. Return 56. That 56 will come here and that 56 should be copied into which field? This field. Now tell me how you access this field. This field can be accessed using C dot D. So here what we write? C dot D. I hope you understood. Now tell me what we are doing here. We are reading one fraction. We are reading the second fraction. We multiply only the numerator, and here we multiply only the denominator and store the result in C dot n and C dot D. Our job is over. Only thing is, now what is the result? 8 into 7, how much? 56. So this is 8, this is 7, the result is 56. 56 should be copied into which variable? C dot D. So here I write 56. Now once you store the result, next what we should do? We should display. So here we have to access C dot n. C dot n means what? 12. Next we have to access C dot D. What is C dot D? 56. So C dot n, C dot D, both are of type what? Integer. So we use percentage D and result equal to. So if I want to display this result, we require which function? Printf function. Now all these statements must be enclosed within braces like this, and here I write void main. Now the declaration of printf and scanf is available in stdio.h. So go here and write hash include stdio.h. So this is the complete program which is used to multiply two fractions, but remember we have used a function multiply. For that we are not passing the structures, instead we are passing members of the structure. That is the reason we say here passing structure members. Now tell me what are all the activities? Activities done when a function is called are: first one, the return address and the values of actual parameters are pushed onto the stack. That is last in first out data structure is called stack. What is a stack? That we explain in the later classes. And point number 2 is, as the number of actual parameters increases, the size of the stack also increases. So if you observe here, the values of the actual parameters are pushed onto the stack. So as the number of parameters increases, the size of the stack also increases. Third point is, as the size of the stack increases, the memory space utility also increases. So that is the reason, instead of using passing structures, we go for, instead of passing structure members, let us go for passing structures. See the disadvantages. What is the first one? As the members of a structure increases, the number of parameters also increases. So it is difficult for the programmer to type all members of a structure as parameters. Second one is, as the number of actual parameters increases, the size of the stack also increases. As the size of the stack increases, the memory space utilized also increases. And the fourth point is, hence it is not good practice to pass what? The members of a structure unless we are passing very small numbers. It is not a good programming style and its performance decreases. This method is inefficient when the structure size is too large and require more memory. That is the reason I said, if you observe this point, this method is inefficient when the structure size is too large. So in the previous case we have the size of, see, when the structure size is too large, is this structure too large? In the previous case we have only two fields. That is the reason we could pass a.n and b.n as arguments to the multiply function. But remember, as the members increases, as the size of the members increases, so the time taken also increases and it requires more memory. So the above disadvantages are overcome by passing structures as actual parameters. So let us not pass the structure members, instead let us pass structures themselves. Now let us see how to pass structures to the program, to the function. Now let me take the same example. I take 3 by 8 and what does this 3 represent? Numerator. So I write n is numerator which is of type integer. What is 8? 8 is a denominator which is also of type integer. I want a single fraction, so I enclose them within the braces. I write a type definition structure. So here what should I write? The keyword struct I should write. Now tell me what type of structure it is. It is a type defined structure. So what should I write? Derived data type I should write. So let me write fraction as the derived data type. Now 3 divided by 8 must be multiplied with 4 divided by 7 and the result should be copied and we should get the third fraction. This is the first fraction, this is second fraction, this is the fraction obtained after multiplying. 3 into 4 how much? 12. 8 into 7 how much? 56. Now let us see how to multiply two fractions by passing structures. Now let me say A, B and C are of type what? A fraction. So what will happen? Numerator and denominator, 2 bytes for numerator, 2 bytes for denominator, and entire block is identified by the name A. Again, if I say fraction B, for B also numerator 2 bytes, denominator 2 bytes, and this block is identified by the name B. Next, there is one more variable C. C is also of type what? A fraction. So what we should do here? Allocate the memory for n, allocate the memory for D. This n takes how many bytes? 2 bytes. N stands for numerator, D stands for denominator. So this entire block can be accessed by the common name C. Now tell me how to read the data into this. A.n, ampersand A.n and ampersand A.d. So I had to use format specifier %d and %d. So here I write scanf. Before that we write printf fraction 1 x/y. Now if I enter 3 divided by 8, that 3 divided by 8, 3 will be copied into numerator, 8 will be copied into denominator. Next, on similar lines I can write scanf %d/%d ampersand b.n and ampersand b.d. Normally before scanf what we write? Printf. Printf enter the fraction 2. Now, so if I enter 4 divided by 7, 4 will be copied into b.n, 4 will be copied into b.n and 7 will be copied into b.d. Now what we have to do? Given two fractions we have to multiply. So here I use a star operator. Let me multiply and let me store the product of A and B into where? Into the variable C. Now let me assume to multiply these two, what we require? The fraction a is required and fraction b is also required. So let me write a comma b here, and I have to multiply. So let me assume there is a function by name multiply. After multiplying two fractions, 3 divided by 8 and 4 divided by 7, what is the result we get? 12 divided by 56. 12 by 56 we get. That is also a fraction. And that fraction will be given by the function multiply. Let me copy that into which variable? C. So a is what? 3 by 8. B is what? 4 divided by 7. And if I multiply, what I will get? 12 by 56. The 12 by 56 should be copied where now? C. So here I get 12 divided by 56. So 12 in the numerator and 56 in the denominator. So let me display. What to display? C dot n, C dot d. For displaying integer values, what should I write? Percentage d, percentage d here. So we write printf result equal to percentage d slash percentage d c dot n comma c dot d. Now tell me what is the output we will get? 12 slash 56. And all these statements must be enclosed within braces like this. And then we write void main. The declaration of printf and scanf is available in stdio.h. So you should go here and write hash include stdio.h. Now the problem is how to multiply these two fractions. So let us write the function multiply. For that, what we require? Two fractions, x and y. X is one fraction and y is another fraction. So enclose those two within the parenthesis like this. Now what should be the result? Result also should be a fraction, because if you multiply this fraction with this fraction, the result will be a fraction. So let me store, let me use a variable z temporarily. Now x dot n, I have to multiply this x dot n with what? B dot n. Here instead of b what we write? Y. Instead of a what we are using? X. Instead of b what we are using? Y. So here a dot n, a and b means this and this, and that a and b is nothing but what here? X and y. So a and b is nothing but what? X and y. So x dot n multiplied with y dot n. X dot n is 3, y dot n is 4, and the result must be copied into z dot n. Similarly, this is what? X dot d, this is x dot d, this is y dot d. 8 into 7, how much? 56. So x dot d into y dot d, that should be copied into where now? Z dot d. And let me return the result as z. Now 1, 2, 3, 4 statements are there. Let us enclose those 4 statements within the braces like this. Now we know how to read two fractions, how to write a function multiply, and how to call the function multiply. Remember, what is this a and b? A and b are not the members inside a structure. A and b are what? Structure variables. So we are passing structures. Now we know how to pass structures. In the previous example, we have seen how to pass members of a structure. Here we have seen how to pass structures. I think we can stop at this point and let us continue in the next class. Thank you.